The next presentation is by Nikolai Shabalin, Integrated Assessment of Atlantic Walrus Foraging Resources in the Pechora Sea during the research vehicle Kartesh expeditions in 2015-2020. I would like to speak about the foraging resources of Atlantic walrus in the Pechora Sea during the 6 years of expeditions of the research vehicle, or research vessel rather, Kartesh. It was performed by our center, Lomonosov Moscow State University. We also had colleagues from the UK. First, we will provide the plan, we will discuss the area, we will discuss the foraging resources. We will also cover litter situation, or rather garbage situation, and possible solutions. We will not go into details about walrus. We understand what they eat, so it's very important to protect and conserve its forage and food objects in order to preserve the species. The area is between islands Vaigach, Dolgi, and Matveyev. We used satellite tags to find the most frequently visited hollow site by walruses. That's why we selected it. Walruses use these regions for foraging, but we must understand that anthropogenic impact is growing with years. More ships are coming by. Crabs are also basically invading this area in Barents Sea, in Pechora Sea. These crabs basically eat the walrus's food. So why exactly that? If we take a look at this, why exactly Pacific snow crabs eat the food of walruses, it turns out that the only area which we are really interested in is that colored area. Based on the task to comprehensively describe the structure of foraging system and the condition of the food objects, a lot of oceanographic studies were performed during the 6 years to study benthos. We used different seabed trawls of different versions: sea trawler ocean 0.1, 0.25, sea trawl 6B, super gnome plus, in order to assess the biodiversity of the macrobenthos of the region. We studied the trophic niche of snow crab. It turned out that there are many more snow crabs when we presumed. Here is a selected sample to assess the marine debris filled with plastic. So the conclusions: the main value is mollusks, The average biomass of macro zoo bentos is 147.11 plus minus 7.35 gram per square meters. The northern and the southern parts of the range are taken by the societies of Astarta borealis and Chilococardium ciliatum, which have high biomass and highly contribute to the foraging of Atlantic walrus. The central part of the range and the sand ranges are taken by the Astarte montagui and Macoma calcarii with low biomass and low foraging ability. We also studied wastes of walruses. We also analyzed different spectrum of what was left in the wastes after they foraged. We sequenced these wastes, and based on these results, the food spectrum provides enough evidence. Not only we performed this work, we worked together with Institute of Oceanology. The results are quite good. The foraging resources are not evenly distributed. There are certain regions with very dense biomass, and there are areas with very low density. The most dense is at a depth of more than 25 meters. In order to study the dynamics and trends of macro bentos, you can see this table for different years and different stations. We had 5 stations to study the benthos every year. The presentation will be available. You can check the table afterwards. What can we say after the 6 years? For biomass, for abundance, for sex, for age is quite stable, and there are no real trends in changes. In this case, the patches covers the time difference, so the spatial difference is so heterogenic that it's not possible to find if this benthos is eaten out or not. That's why it's covered by the time difference. We believe that one of the reasons is very long distance from Atlantic streams and mainly present in the Barents Sea. Based on the information available, on the climate factors, on the biological factors, benthos communities are affected by these factors, but we need more data, we need more expeditions to see certain dynamics, but some results are very troublesome. If we speak about mobile macrofauna, based on the video footage, there were different animals detected, including snow crabs. So instead of aircrafts, we use special cameras which go on the seabed and they register different animals and they register their speed. Snow crabs, spider crabs also occur, and snow crabs was 15 times more than in 2016. Taken into account all the information available that this is a very invasive species and is actively trying to get into the Barents Sea, we can see that from the footage, invasion is quite active from the snow crab side. This is a preliminary data. We believe that the sample is not big enough to state it clearly, but this year we will try to get additional information to double check it, because this is a red flag in terms of Pechora Sea. This became very problematic because snow crab basically has eaten out everything from the sea bottom. There are works which demonstrate this. If the same happens in the Pechora Sea, then walruses will have nothing to eat, but we have to double check it. In order to understand how their diet overlap, we analyzed diet of snow crab, we analyzed the content of its stomach, what they eat. We collected more than 150 samples. We provided necropsy, we analyzed what was left in the stomach, we analyzed the wastes of these crabs, we analyzed organic and inorganic. This is what we can see about the diet of the snow crab. They intersect with other crabs' diet. They accumulate very fast. Well, basically, it's faster and more than other crabs, and they compete with other bentosphagous or other animals which have the same diet, including walruses. We were able to find microplastic at 3 stations, but we have to continue this work. Of course, we understand that the more biomass is, the more microplastic we find. The maximum result is 34.8 for snow crab. But for different other species, for mollusks, we can also see that they have quite a lot of microplastic, from 10 to 20 to 30%, which is very troublesome. To close my remarks, I would like to say that average biomass is 150 gram per square meter is by mollusks. Snow crab has overlap in diet with walruses. Preliminary analysis demonstrates that the occurrence of snow crab has increased, significantly increased, but we have to double check it. On average, in 21% of cases of studying the stomach of crustaceans, of mollusks, microplastics can be found. Snow crab occurs a lot, and we could find a lot of microplastic in snow crab because, as I said, they eat faster and they eat more than other marine animals in this area. The area is very heterogenic. There are different animals there, and analysis covers both different areas and in different time frames, but we see changes, which is very important. So we continue to work on year-to-year monitoring, to collect data, to analyze the changes, the trends, and to see how much microplastic we can find in the stomach of these animals and how snow crab affects other species. We also want to study wastes of walruses for the presence of microplastic, and also analyze snow crab DNA, because sequencing of this crab has not been performed. We still need to understand the role of snow crab in the foraging of walruses. And in 2022, we plan to analyze foraging resources. We also want to analyze the ground and find mollusks which bury themselves deep, and also study them. We studied them back in 2016. I want to see the difference in 5 years. Thank you for your attention. If there are any questions, I am ready to answer. Thank you for your very interesting presentation, but unfortunately we don't have enough time.
I want to take advantage of the role as a chairperson and want to say that Nikolai's presentation, we all together, we applied Pechora Sea for the forage resources of walruses. Ideally, it shall be replicated to other areas. First of all, we need to identify the areas using satellite tagging, do survey and analyze species of walruses. Then we will have the comprehensive complex of actions that will be able, so we will be able to arrive on a big and comprehensive picture.